Florian Pappenberger's group here at ECMWF, including also Ben Lloyd-Hughes, who's at the University of Reading. Global drought monitoring, as well as actually global flood forecasting, is currently incorporated in the GEO work plan. But today we're only going to be talking about drought. There we go. And what I'd like to talk about today is try to ground what we are doing in something which is actually practical and concrete. And from that frame of reference, showing how some of the global drought monitoring is not intended as an exclusively academic type of enterprise, or even perhaps climate research oriented, but how it's actually grounded in societal benefits in terms of actually providing some tangible benefit to a user community. And the user community for which we've been having the greatest impact and greatest influence is predominantly those organizations that are involved in famine relief, such as FuseNet, which is a USAID organization sponsored in the USA, and Oxfam and other organizations which are worldwide, the Red Crescent and the Red Cross and Save Our Children. Then I want to basically go into looking at drought. Like, obviously there is quite a lot of active interest going on in terms of monitoring drought on the national level. Recently a meeting was held in Geneva on the new ways of trying to buttress national drought policy in terms of the high-level meeting that was held by WMO in Geneva. And however, at that meeting, there was really not any emphasis placed on the global level, which is not to say there's not interest there, certainly on the part of WMO. But what we're going to do is basically talk about the associated global aspects. And then we're going to talk about the monitoring technologies, like what are some of the processes of drought and how the time frames and the spatial scales determine how you can try to track drought across different types of scales. Okay, so to start off with, why is global drought early warning needed? Okay, and to be able to answer that, what is famine and how is famine actually classified? Well, an international group has been organized to try to codify a set of famine criteria that would be used as a basis for declaring an area or a nation as being subject to famine in order to qualify for humanitarian assistance. And this is, as you can see in the next slide, I don't expect obviously anybody to read this, but basically what it does is the information to be shown is that at the top in dark green, you have a generally food secure type of nations or regions, to which you have at the very bottom famine or humanitarian catastrophe. And obviously in the case of drought, we're interested in looking at the bottom two categories, which are humanitarian emergencies and famine, humanitarian catastrophe. And the next slide is basically a little bit of a clarification in terms of what are the ballpark or baseline mortality rates and malnutrition rates in terms of population statistics or population per capita values that are used for classifying these states, as well as other types of criteria that are used to determine this condition, such as the number of livelihoods, the proportion of livelihoods that are impacted, as well as access to markets or available food supplies in the local region. Okay, so the Interagency Regional Task Force, which has been or was involved in the Horn of Africa drought in 2010 and 2011, and is the Food Security and Nutrition Working Group. It's hosted by FAO, and the World Food Program is also involved, including other UN agencies, FuseNet, who I mentioned earlier, ECTAT, the Red Cross and the Red Crescent, and other representatives, including Oxfam. Okay, so what I'm going to do here briefly is go through a few slides You can see here that the coloration is used to determine the proportion of land area for which is subjected to catastrophic famine, which is considered to be an emergency food or basically food insecure type of situation, what is stress and what is actually not subject to stress at all. The point that we're obviously leading up to here is how do agro-meteorological or agro-climatological inputs enter into this system, i.e. how do we basically incorporate drought, especially in an area where the interruption of food supply is determined by drought type of conditions. Okay, and so the answer is, like, what do you do in a situation such as Africa, where basically the meteorological ground-based infrastructure is very sparse, the station density is very low, and you have stations that either report late or do not report at all. Obviously, in order to be able to provide food supplies for an emergency condition, you need to have immediate up-to-date information. And if you have meteorological stations that are basically supplying information a month later, then that's not going to be of much help to you. So part of what we're doing, what we've been trying to do, a multitude of partners within this effort, of which the Group on Earth Observations is one partner and a facilitator, is to try to see how satellite remote sensing can basically fill the gap and provide equally as much certainty as is provided by some of the ground-based statistics, which are basically predominantly based upon precipitation. Okay. Now, what is currently done in terms of being a technique and methodology employed by FuseNet is to use existing remote sensing imagery provided by the MODIS sensor, which was launched by NASA. And what they are doing there is looking at something which is indirectly influenced by drought, indirectly in the sense that they're looking at vegetation and the impact that drought and water stress has in terms of changing either NDVI signatures or some other property of vegetation. In the case of, say, for example, the Drought Research Center, this would be the fraction of absorbed photosynthetic active radiation. There are other methodologies that are being used. NOAA CPC has developed what's called the Vegetation Health Index and the Vegetation Condition Index, which is another type of way of looking at vegetation which is being stressed by drought in order to be able to provide the information. The point that I want to bring home here is, however, that the actual product, in this case the remote sensing product, is delivered within 3 to 5 days of acquisition, which you can see from the bottom line here. And so this gives you, say for example, and this is the actual data flow or data processing diagram. So within 18 hours, you basically have information which is available and can be used by decision makers. And in the case of the Greater Horn of Africa drought, this information was used to basically help evaluate in terms of the food supply situation in the Horn of Africa drought. Now the question is, we know that basically stresses to vegetation is something that arises obviously at the end of the process. Can we try to go back earlier into the process in terms of trying to determine how the impacts of drought in terms of different stores of water in the water cycle, which is cycling through an area? Can we basically tap this source of information to be used to provide a space-based system, which we can then complement with the land-based information we have in terms of precipitation records? Okay. Now, having said that, I want to say that basically provides the overview in terms of saying, identifying who one of our major user groups is. And the next point of the talk is in terms of looking at, okay, why would we want to have global coverage for drought? And the obvious answer is that drought does not stop at national borders. A classic example is what occurred this actually last year in terms of the severe drought in North America, where both Mexico and the U.S. were basically equally affected by a very large, almost super drought, which is basically a very large continental scale type of drought conditions. The second factor is that in different parts of the world, basically the WMO recommended standard for meteorological observations is not being met. Central Asia is one, obviously Africa is another. So can we provide some basic coverage that would be able to provide service to these areas in terms of providing disaster and early warning type of activity? Okay. Now, having said that, I'd like to step back and say that drought does not end at a national border. And this is an example showing two things. First is that I think that we may be getting possibly a biased view of the possible impacts of drought by even restricting ourselves to something as certainly as short as the satellite record in terms of the existing satellite record, record of data duration, and even the instrumental record. There's been a lot of really excellent work trying to synthesize dendrochronological information, tree ring information, to reconstruct the prevalence of drought where the existing sampling is high enough in terms of tree ring sampling in given areas. And one product which is already being produced systematically in the case of North America is a product going back to literally the first millennia in terms of estimated or recreated type of drought prevalence in over North America. And this is an example of what a potential super drought looks like in the case of 1399 in the case of North America, and also in the case of 1444 in the case of North America. And this is also an example of a super drought which has been based upon reconstructed Chinese predominantly and some Russian dendrochronological evidence which has been used for recreating the 1877 Great Victorian Drought in Asia, which shows the potential impact in terms of areas impacted. So this is starting to offer some evidence showing why having continental scale drought coverage is really important. And of course, in the case of areas where the oceans are exerting influence in maintaining existing drought patterns, obviously this is also a situation where the monitoring needs to extend beyond the continental scale. Okay, so having said there, I want to shift to the next part. We mentioned earlier that what we would like to do is try to find some type of evidence to monitor drought which is at an earlier stage of the drought process, the drought cycle, before vegetation itself is actually impacted. Now, what I want to do here is, this is an example of the 9-year millennial drought, almost decadal drought, which existed in Australia. And you can see the impact it had in terms of the decline of surface water storage that occurred in southeast Australia in the Murray-Darling Basin. Next is that, as said before, it was basically a durational drought. The point to be made here is that had one, to go back, okay, no, there we go, to go back, if you look at 2005, basically this was a period of time where during 1 or 2 seasons, the precipitation was near normal, just below normal. And then basically the precipitation started to fall precipitously beyond that point, and the drought was basically prolonged and maintained. So if we had just gone ahead and used a length of Standardized Precipitation Index for 3 months duration, for example, during that 2005 period, then you would reach the conclusion that you had just below a near normal condition. You'd basically given a distorted view because you would actually be in the middle of a drought. So Traditionally, what this means is if you use an index such as Standardized Precipitation Index, you want to take multiple time periods of duration in order to construct such indices. You want to take 3-month intervals, you want to take 6-month intervals, you want to take 9-month intervals, you want to take yearly intervals, because then you can basically compare the results and see whether or not you actually have drought occurring over the longer period. Okay. So moving on. And this is an example where we actually reconstructed various types of water measures. The first is actually the incoming precipitation record based upon the extensive rain gauge maintained by the Bureau of Meteorology and over Australia, the Commonwealth. You also have the ASCOT you have the ASCOT soil moisture measurements, which are basically remote sensing surface, skin, soil moisture measurements over Australia. You have GRACE, which is a Gravity, Recovery, and Climate Experiment satellite, which is measuring total water storage in a given area. And traditionally, how GRACE is used for drought monitoring is in combination with data assimilation with a modeling package, which includes multiple stores of water and fluxes of water, fluxing from the actual surface water, including runoff, into groundwater. And then you basically subtract out and separate snowmelt runoff. You include changes of groundwater, and you include changes of surface water. The bottom line here in this actual diagram as a whole, you can see that, as you saw from the previous diagram, the surface water storage is in decline up until the termination of the drought in 2011. And so you also see that the very bottom diagram, which is groundwater, is in a state of continual decline. So basically, this is a situation where you have a process called drought propagation. What's happening is the precipitation inputs are not there, so your soil moisture is draining off. Your soil moisture is draining off as stream flow. Your soil moisture is draining off into groundwater, and the groundwater in turn is cycling and basically being depleted as well. Okay, so in order to be able to actually monitor drought and to identify drought, monitoring multiple stores of water can be very, very helpful. Okay, so what we did was, in addition to looking at multiple stores of water and different stages of the water cycle, we've looked at spatial scales. The question is, what about time scales? Well, one thing which has been uncovered is due to the extent of the observational analysis, both of the 2010 and 2011 Russian droughts, as well as the 2012 North American droughts, is that there is a fine-scale temporal structure that is present within drought. And basically, the term which has been coined for that in the case of the U.S. is a flash drought. What this generally means, translated in English, is that if you have heat wave type of conditions, the combination of high temperatures and the combination of strong winds can basically deplete soil moisture in a given area and basically speed up the exacerbation of drought conditions. And the flash droughts occur over time scales on the order of about 2 weeks, which is what was just said there. Okay. Now, having said all this, what we're going to do is quickly move into the monitoring phase in terms of how one can go about monitoring drought, both in terms of combination of ground-based information and remote sensing information. The point to be mentioned here is that drought depiction is undergoing a bit of a renaissance within the USA, partly as a result of the National Integrated Drought Information System, or NIDIS. And what is occurring is trying to take all of the traditional legacy types of means of measuring drought, which include the old Palmer Drought Severity Index, which is actually on the way out, so to speak, except for in the case of trying to reconstruct, say, for example, drought which occurs in the pre-instrumental period. By supplementing this with new space-based type of monitoring capabilities. And two of these space-based capabilities include the Evaporative Stress Index, which is a thermal band principle based upon evaporation as opposed to precipitation. And given the fact that it's based upon evaporation, that means it is not dependent upon precipitation measurements. So what that means is that in theory, what you can do is you can construct an energy balance based upon space-based sensors. You can then go ahead and, based upon the energy balance, solve for the sensible heat flux. If you have ancillary meteorological information, such as the ECMF, reanalysis data, fields, which are real-time, and then having the sensible heat flux, you then solve for evaporation flux. And then you take the measure of actual evaporation or evapotranspiration divided by potential, which gives you an estimate of what the actual ratio of evaporation is in the area. And this methodology has been developed for actual implementation, operational implementation in the U.S. And this methodology has been actually very extensively tested. It's been very extensively tested by the U.S. Department of Agriculture. What they've done is they basically separated out drought episodes from the chronological record in North America. They basically tracked how, say, for example, this methodology, the ESI, the Evaporative Stress Index, compares relative to SBI, and the correlation is very, very high. Another methodology, which is the second methodology, which is mentioned here, is the GRACE, data assimilation, which was mentioned briefly earlier. And the third is, of course, the Vegetation Health Index, which was referred earlier. Now, I might add that a lot of effort has been made developing some global capabilities for Vegetation Health Index. This methodology, the Vegetation Health Index and the Vegetation Condition Index, is now in the process of being very, very carefully validated relative to the more standardized and more accepted SPI methodologies. And the reason for this is because there has been some question that the methodology fails predominantly in the higher latitude areas, such as Canada, the boreal zone areas, basically, in both Alaska, Canada, and in the case of the Russian Federation. So now what's happening is there are studies currently underway in order to evaluate, to make sure, to determine the limits of viability for this methodology. Okay, I'm going to move quickly on now. This is an example showing how the Evaporative Stress Index is indeed actually implemented. As you can see, it is currently incorporated within the NIDIS portal, and this is an example. In fact, this is an example of Evaporative Stress Index, which was from last week, actually. And as you can see, it's expressed as the degree in terms of anomalies relative to a standardized set of conditions, like most of the, including SPI, I might add, most of the drought methodologies. Okay, the GRACE-based methods, which are basically the gravity recovery and climate experiment methodologies based upon total water storage. This is an example of now how it's currently being presented and made available to users in the NIDIS portal, in the Drought portal back in the USA. And this is an example of its preparation for surface soil moisture. Now, the way the process actually works, and I'm just going to make a brief comment here, and you'll see more about this in the last few slides, is that you have all of this input information available. In the case of North America, there is a process called the North American Drought Briefing. Experts get together from 3 countries, Mexico, Canada, and the USA. They basically take all of this information, then they go ahead and basically judge and evaluate the inputs and try to put together a final map based upon the final results. Okay. Okay. Now, since we're talking about global drought as opposed to U.S. drought, or say drought as monitored by the European Drought Observatory, or even drought over Africa as monitored by some of the regional drought centers there, how do we go about trying to set up and develop set up methodology for monitoring drought at the global level? In terms of using not some of the existing synoptic-based methodology in terms of precipitation records, but in terms of trying to use some of the remote sensing-based measures. And one technique is to use geostationary type of satellites. And so this slide is an example showing how one can basically use simultaneous geostationary satellite coverage, and based upon that, basically create something such as what you see in this figure, which shows the extent of coverage by all the geostationary satellites, which would be able to then produce a continuous real-time drought monitoring system based upon that. If you look carefully, you can see that there is a gap in coverage over the Russian Federation, which is located right here. And the reason for that is that the Russian geostationary satellite, or actually environmental satellite, is not included, which is something that we're trying to basically work on here. Okay. What I'm going to do is I'm running out of time, and I'm going to quickly go through the remaining slides. What I want to, so this is an example showing here, and I can summarize this very quickly by saying that what we have done and what we are doing is trying to approach global drought from a multitude of both institutional points of view as well as methodological points of view. To be able to look at the institutional points of view, what we're doing is we basically have GEO and other organizations, including NOAA, have basically been trying to go ahead and establish networks, continental scaled networks, to have all of the hydrometeorological services which exist in a continental area, have them basically engage in data sharing, to share drought information so that we can produce continental scale drought coverage, which we then can integrate together into a global picture of drought. This is something which can then be complemented with the space-based global coverage. And this is an example of what is being produced by our partners in South America at CPTEC in Brazil. This is an example of South American land data assimilation, some of the 1-month drought forecasts that they are making. However, in this individual case, what you're seeing here is not actually a forecast. It's actually a monitored product which exists in terms of soil moisture percentiles for the 2005 Amazonia drought. The message here is, as you can see in the case of the red splotches, basically the lowest soil moisture percentiles, which tags and identifies the drought conditions. Using Standardized Precipitation Index, this is where the precipitation products which are available for South America are basically being used. And if you compare the slide, and in my presentation will be available, you can look at in detail. But basically, the precipitation information, as you would expect, precedes and leads the soil moisture maps. Okay, so this is more detail basically on the GRACE system. This quickly, I'm going to summarize here. This is an example of how the GRACE product actually looks. This was the 2007 Southeast drought. As you can see, there's a significant drain in terms of total storage, water storage, groundwater that took place in the case of the drawdown of groundwater in the USA during the drought. All of these information, this is for Iraq, since we're talking about global situation here. This is India. Now, so that is an example of some of the methodology which is available. I've provided an example for South America. Now, what we've done is we basically have assembled the information on a portal for the global case. And this is an example of the global portal, which is currently now housed on the NIDIS portal in the USA. You can see we have coverage in terms of real-time drought coverage for North America. We have it for parts of South America. We have it for Australia, China. We have coverage from the China Meteorological Administration. We have African coverage, predominantly actually from the Princeton University African Drought Monitor. However, we have coverage in the pipeline to be added from the JRC, African Drought Observatory, and DEFORA, the Drought Early Warning System for Africa, and other sources as well, including, I might add, Ben Lloyd-Hughes' global SPI information. Okay, I'm going to quickly summarize here by saying this is how you can actually access the global portal. Like you basically go just to drought.gov. You can see here, global. Just click on that and it will immediately take you to the global coverage. Here is Ben's coverage, global coverage, and you can see this is the SPI information. Oh, I'm sorry, including a statement of current conditions. This is some of the organizations that are currently participant. The final message I want to make here is that, again, as said in terms of drought relief, we don't want to just stick information on a portal. What we want to do is we want to try to make this information available to real users. So with that in mind, what we're doing is we're taking and creating a process which is similar to what is being done in North America. In North America, what you have is you have a situation called the North America Drought Briefing. What we're doing is here we're creating an analogous situation where you have a global drought briefing, whereas experts would get together at the start of the growing season, the crop growing season we're talking about obviously here, for North America and for South America respectively, and then go ahead and look at the remote sensing-based drought information, look at the land-based drought information, and come up with what a estimate would be for actual existing drought, as well as what, say, for example, a 1-month drought outlook would be. And this is one situation where our partners here at ECMWF, and I want to add as a last slide, since ECMWF has been kind enough to host us here, that what they're doing is they're providing a valuable, actually invaluable opportunity for looking at drought from a global point of view by assessing drought linked to the ECM both monthly and seasonal forecast system in terms of trying to look at and get a first look at to what extent, how hard, and at what degree of uncertainty do you have for different regions of the world in terms of looking and trying to look at drought for these respective areas. Okay, and so thanks very much.
Okay, thank you very much, Will. We'll take questions now, and we have also people attending in the room where we're speaking and online. So if anybody from the room would ask a question, I ask Will to repeat it. Otherwise, I let the floor free.
And I would say also that for those that are hopefully interested, feel free. I mean, a copy of the presentation will be downloaded, and you can just email, and I'll be glad to continue and answer questions, offline in that area as well. Sure. Sure. Yes. 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 Yes.
How much of that trend in the groundwater is actually driven by the overlying hydrology and water propagating systems, and how much of it is driven by increased demand for extraction?
Yeah, that's a very good question. And
repeat the question first.
Oh, yeah, absolutely. Ben just asked the question in the case of the Murray-Darling Basin, and I might add that that's actually quite a good question because we actually, as Ben knows, we spent a full probably year and a half exhaustively exploring drought, especially the millennial drought over Australia. And part of the reason for that was because the actual observational record in Australia was invaluable. In fact, I would say actually the operational record in Australia probably outshines the operational capabilities in terms of the water record capabilities of even the USA, both in terms of groundwater monitoring as well as soil moisture monitoring, as well as what have you. So it provided an invaluable opportunity for us to not only evaluate, say for example, monitor what was going on, different stages of the water cycle. But the second factor was the fact that ABARES, which is the Commonwealth agency, which is the agricultural agency in Australia, they have a statutory obligation to monitor water use in the Murray-Darling Basin. So they have an extensive record, as does CSIRO, I might add, in terms of monitoring water use in the Murray-Darling Basin, MDB. So what we did was, it was an ideal opportunity, almost like a laboratory example, for us to be able to go in and separate the intervening variable of human use in terms of consumptive use of water versus the depletion of water due to natural causes, i.e. the drought condition. And in this individual instance, it was clearly a drought signature, which was independent of and added to the monitoring. I might add that this was a positive feedback loop in the sense that the MDB is a heavy regulated system. In fact, actually the Murray and the Darling rivers are not even normal rivers anymore. They're entirely regulated rivers. And so what was happening as a result of the water scarcity, there was efforts going on to basically shift and manipulate the flow of water within the respective basin. Now, springboarding from that to the global level, that's a good question. And obviously in the case of an area such as Central Asia, where you have the Kyrgyz Republic, where you have Kazakhstan, where you have a country which is highly dependent upon snowmelt runoff, where the precipitation inputs from precipitation, liquid precipitation, are not as extensive as a snowmelt runoff. Obviously, and you have a situation where a lot of the water flows are horizontal. You have a situation where the river flow is entirely regulated again, and you have a situation where basically water use upstream is determining water availability downstream. In a situation like that, obviously, that is a situation where the human use of the water scarcity issue, by far has a greater impact on the system than, or is in terms of the signature when superimposed on the drought signature. So that obviously, as you might imagine, is a thornier question, because the question is, do you have the information, the observational information then, and do you have the management, the water management information then, to be able to separate out the relative influences? And I would say no in Central Asia, I don't think anybody in the room or anybody even in Central Asia would deny that. Certainly in the World Bank, they would not deny that. That is part of the reason for the World Bank effort to modernize the hydrometeorological services in Central Asia. Now, if you talk about South America, for example, where the infrastructure is not as extensively developed as it is in the case of, say, for example, North America, Europe, or Australia, that may be a different situation. Because obviously, in the case of Argentina, there you do have more information which is available in terms of agricultural uses of water. So I would say maybe there's a possibility where you'd be able to separate out the actual water, the human uses of water and the consumption of water, like relative to the actual losses of water from natural causes like such as drought. So, yeah. Any other questions? Yeah, I saw you had two questions. Yeah. Yeah.
Well, my other question is about non-stationarity of time series.
Yeah, and
the drought measurement shows
yes.
The relative some kind of standardized base.
Yes.
And you flagged that you've got the short-term record, particularly the satellite record.
Yes.
May well be biasing in climatology.
Absolutely. Yeah, in fact, I would even go further.
Can you please repeat the question?
Oh, I'm sorry. Yeah, actually, Ben again asked the question, like, obviously, we have a situation where there's a very famous article actually published in one of the journals in the U.S. about the death of stationarity, especially as far as the climate record is concerned, obviously. And so, how does the death of stationarity impact our records? Our data records, the length of our data records, since obviously both the Standardized Precipitation Index, it's based on the assumption of a certain amount of stationarity and a certain amount of homogeneity with regards to records in order to be able to separate out drought conditions, dry spell conditions, normal conditions, and wet conditions and flood conditions. And so I can even, and so the question that Ben was asking is like, how does this impact our records? Well, I would even go further than that, because basically my colleague Justin Sheffield in Princeton, he has been attempting to mate, to produce using the VIC, to produce a global water monitoring system of sorts. Now, obviously, the VIC model does not include groundwater, so it's limited in terms of some of its capability. But what he does is he takes a long-term data record, which was basically produced as a result of using a combination of reanalysis with observational precipitation data, the meteorological fields being produced by reanalysis data, a 30-year record, 40-year record. He's up to a 50-year record now. The Japanese are up to a 100-year record. And however, when it comes time to trying to produce an online or real-time system, you have to mate these existing long-term records with some operational product which inherently is generally remote sensing based. And what Justin discovered is that there are different trends in the operational record and the long-term data record. So how do you reconcile the two? And that's part of the problem. And so I think that is, something that is a research issue that we're trying to deal with. But to get back to the fundamental question, okay, I think that's a good question, and that's actually the very reason why I presented the slide which showed what is believed to be the spatial extent of the super droughts that occurred during the pre-instrumental period. Because I think that when we start to have more maturity in paleoclimatology, I think that we're going to discover that even within the instrumental record, there's probably going to be a bias. We're going to discover that we're in a set of wetter conditions now than probably existed during the first millennia. And what we're going to have to do is, how is that going to bias, like, say, for example, the ability with which we, determine, drought conditions as opposed to dry spell conditions. All I can say is that obviously this is a question where practicality generally tends to win out, in the sense that basically people don't deal with this issue. Like operational agencies, what they do is they base their information upon the instrumental record, basically, and that is the basis for trying to determine like drought conditions. However, they do not rely exclusively on one index, or even two indices. So they try to complement this with additional information and try to basically provide a fudge factor based upon that. Yeah. So, okay, please go ahead and ask your question. Do you have a question? Okay. And does anybody online or anybody in the audience have a question? Just listening in? Do we have any people still on? Okay.
Yes. Can you hear me? This is Tom Adams.
Yeah, I'm fine. I can hear you quite well, Tom.
Okay, great. You've done a great job in illustrating the points with the observational networks and monitoring current situations, and then with the stationarity is dead theme. We have a good sense that with climate change that is a problem, and it leads to the problem of basic predictability. We can monitor drought, and that's good, and we can react to those problems and deal with the issues. But unless we're able to reasonably predict out into the future with a certain amount of confidence, we're really hampered. And so not only is there just the basic stationarity problem, but there's also the predictability problem as well, and the confidence that we'll have in those predictions.
Yeah, I entirely agree with that. In fact, what we did was, we kind of, to be honest, I ran out of time, and what I mentioned briefly that there were certain institutional developments going on simultaneously, along with some of the development of new remote sensing-based global observational techniques for drought monitoring. To get back to the institutional again, and this will get to your forecasting issue directly, like what we did last year was the World Climate Research Program, specifically the Drought Interest Group, which is actually the outside of USA drought part of the WCRP, which I will admit is biased in the sense of mainly being U.S. people and Canadians. But what we did was we organized a workshop that was held at Frascati at ESA in Esrin, called the Global Drought Information Workshop. It was basically a multi-partner workshop. ECMWF participated, multiple organizations participated, WMO participated, Bob Stefanski from WMO participated, and the point that I want to make is that what we specifically set out to do at that workshop was take the first step in terms of trying to sit down and evaluate the forecasting issue at the global level. Obviously, there are forecasting efforts going on here. There are forecasting efforts going on, existing efforts in Africa in terms of the existing regional drought centers there. There are European framework projects like DEFORA, Drought Early Warning System for Africa, that are being that are underway there in Africa. Obviously, Australia has quite an ambitious forecasting program going on. And the question is, what we're looking at is a transnational type of forecasting in terms of trying to evaluate the limits of forecasting in some of these areas where they don't, where the forecasting evaluation is not as exhaustive as occurring in some of these national or even regional, like in the case of European, obviously, areas. And that's what we're trying to do. And what we did in Frascati, at the GPCC workshop, was to try to, we did actually, link with some of the user organizations and the regional drought centers there in order to try to evaluate how effective some of the SPI-based forecasting methodologies would work for an actual drought situation at hand, which in this case was the Greater Horn of Africa drought. Now, I would hasten to add that this was being done on the back of the existing project there, DeFora. But I would also add that this forecast issue is something which is very actively being explored right now by CPTech in South America. So what you're saying is absolutely correct, and this brings back to how the presentation started, in the sense of how, in order to be able to provide early warning, we need to have the maximum lead time possible in terms of knowing what a drought condition, or at least having a reasonable level of certainty in terms of what a possible drought situation which may emerge is. And so prediction is definitely the way to go. And this is something that we're basically trying to come to grips with right now. So I don't know if that answers your question or not, but that's certainly the perspective that that we've been using so far in coming to grips with the forecasting issue. I can say that talking to my colleagues and my partners, there are differing opinions in terms of how valid forecasting is. Like, for example, there are some people that believe that global forecasting, drought forecasting, is limited to areas where there's a heavy ENSO signal. There are other colleagues that are not quite so skeptical, and they think that, for example, it's possible to have a certain degree of, certainly, I would say, bi-monthly drought predictability to factors such as the memory of soil moisture in areas such as, for example, the USA. So I don't know if that answers your question.
No, yes, it does, and obviously it's a very complex problem.
Thank you for the question. Okay, any other questions?
Okay, thank you everybody for listening online and in this room. This was the third HEPEX talk seminar, and we will have the next one sometime in May. We haven't decided exactly when and what topic, but there will be information going out soon. So thank you very much, Will, for giving this talk, and we conclude this seminar. Thank you.
Thank you. Oh yes.